10-4 Space Figures. Our objective today is to identify features of three-dimensional solids. First ones we're going to talk about are polyhedrons, and they're closed figures bounded by polygons. Some examples would be prisms, pyramids, and other polyhedrons. Prisms start out with two rectangles, somewhat overlapping. One of them should have some dashed lines where it's overlapping with the other rectangle. That's supposed to indicate that you can't really see that edge, that side. Then go ahead and connect your corners of each rectangle, and you have just created a prism. Again, you notice that three of the lines are dotted. That's telling us that they're behind. You really can't see them. That would be a base, and that's also a base. They're parallel to each other. And we could do the same thing with triangles. Although you'll notice here that the triangles aren't overlapping as much, which is okay. So the bases are congruent and parallel. For the pyramids, you have a base and you have a point, and the point is connected to the base. Pyramids don't have to have four sides. They could have 3 sides, 5 sides, 6 sides, so on. But as long as they have a point, as long as they have a base and a point, they're a pyramid. Other polyhedrons could be a mixture of the two, or a mixture of other things. So this one we have what it looks like to be a cube or a prism, but then we put a pyramid on top of it, and we have something new. Maybe it's a house, maybe it's the tip of a drill, could be anything. Then we have our non-polyhedrons, our cylinders, our cones, and our spheres. So a cylinder is going to have 2 circles, and they're going to be connected. And they can be slanted. And that would be considered an oblique. A cone, I'm sure you're probably familiar with cones. We probably have all had ice cream cones. So here a cone. Here the base is a circle instead of a rectangle or a pyramid, or a triangle, that type of thing. And finally we have our spheres, and they're basically just a big ball. We want to use the solid below to name the following 5 vertices. Those are basically the corners, so we have vertex A, vertex B, vertex C, vertex D, and vertex E. Name 8 edges. Well, in the back from A to B, that's a line segment. Then we have B to C coming up front. Along the front we have DC or CD, and then AD. And we also have the lines going up to the edges, the lines going up to point E. So AE, BE, CE, and DE. Finally we have our faces, the square, this face, and that base, whoops. So we have the square ABC, the triangle AED, the triangle AEB, and the triangle BEC, finally the front triangle DEC. The other thing we do is sometimes we'll take a figure and basically kind of unwrap it in a way, or take it apart and lay it flat. So if you take a solid, and here's a picture of a solid, hopefully that looks something like 3D that you would see in the movie theater. And we're going to take and unwrap it. So we're going to take that, and that'll be our start. Then I'm going to take that and fold that over, or unfold it. Unfold that. Unfold that. Basically just the sides. And then I'm going to unfold the top. And that would be my 2D net. The net is just basically everything we have. Everything we have. So that would be a rectangular prism. Let's try the 3D for a cylinder. So think about, how could we break this apart? Well, we've got that part. Basically think of it as like the sides of a soup can or a cola can. And if we unwrap that, we get something like this. Now what I like to show in class is, if you think of this as your cylinder, if you unwrap it, you get this. So you get that rectangle. Then you have your top and your bottom. And it doesn't really matter where the top or the bottom goes, because when you fold them over, you'll get back to your original cylinder. So I'd like you to try to sketch, what do you think the nets would look like for these 3D solids? Do the best you can. Pause the video. When you're done making your masterpieces, come back and we'll see if they look like what I have. Okay. So we'll start with the bottom there, or the side. Then we're going to unfold here. Unfold the other side. Then I have the back and the other triangle. So it should look something like that. For our cone, we've got our circle. And then if we unwrap that, it's not going to be a straight line. There's going to be some curve to it. Next, for our pyramid, triangular pyramid, we've got the base, and we can unfold it. And to me that looks kind of like a flower, but not a really good flower. So we have a triangular prism, a cone, and a triangular pyramid. Now I want to know, if I put these back together, if I fold these up, can I get the net of a cube? And these are a little hard to do by video, but we'll do the best we can. So I want you to think, can you fold these up and have it form a cube? Sorry. So take a moment, and you can just put a Y or an N, and then if you get it right, then you can leave it. Okay, so for number one, the answer is yes. Because basically those can fold over and be parallel to each other. So that would be able to form a cube. If you look at number two, there's no way to get anything parallel with that. So that would be a no. Now, number three is a little tricky, but actually, yeah, you could get those two sides to be parallel to each other. You would fold it up and then fold it in, and the other one folds over. Number four, we could get that one to work. Number five, we could get to work. And we also can get number six to work. So hopefully you're able to see those. Again, it's kind of hard on a video to really truly show what's going on, but do the best you can. And that's it. If you have any questions, post them on Edmodo or ask me in class. Thank you very much.